Hi there, this is the Math Dog. This video goes over the trig identities, what I call the Pythagorean identities. They are cosine squared of x plus sine squared of x equals 1, 1 plus tangent squared of x equals secant squared x, cotangent squared x plus 1 equals cosecant squared x. These and this property that tan of x equals sine x over cosine x. For those of you in the AP Calculus program, the AB test, that's like the Calculus 1 test, these four identities are really basically the only ones that you need. You need to know like that cosecant is the reciprocal of sine, etc. But these are the four identities you need. Now if you're doing the BC curriculum or Calculus 2, you're going to need some other identities to get through that course. So let's get going. Okay, so review, very basic trigonometry. Trigonometry is initially based on a right triangle. So I'll call this x, this y, and this is the hypotenuse. I'll call it r. So we have SOHCAHTOA. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent side. So from the perspective of angle theta here, this is the opposite side. The hypotenuse is always opposite the right angle. Just put HYP. So what's left over is the adjacent side. Okay, that's how I always figure out what the adjacent side is. I first identify the opposite and hypotenuse in a triangle, and what's left over is the adjacent side. So sine is opposite over hypotenuse, so from this diagram, sine theta is y over r. So therefore y is r sine of theta. Cosine theta is adjacent over hypotenuse, so it is x over r. So x is r cosine theta. And notice that tangent is opposite over adjacent, which is y over x, but y is equal to r sine theta, and cosine, or x is equal to r cosine theta, which gives me the identity that I just talked about in the opening. Tangent theta is equal to sine theta over cosine theta, because the r's cancel out. So then we have other trig functions. We have the sine, and by the way, sine is actually spelled S-I-N-E. That's not sin. Don't say sin in your class, because that can probably make, especially if you're in like calculus or something, because your professor's probably going to not look at you very favorably and think, how did you get through trig to get into this class to begin with? So sine is spelled S-I-N-E, cosine is spelled C-O-S-I-N-E, and tan is tangent. So reciprocal sine is cosecant theta, and that's spelled cosecant. The reciprocal of cosine is called secant. And reciprocal of tangent is called cotangent. So these are just abbreviations, all these. All right, let's continue. So now the unit circle is very important in trigonometry. So the unit circle is simply a circle with radius 1. So for example, here's a point 1, 0, because this is at this position. The coordinate of x is going to be 1, y is 0. If I go straight up 90 degrees, this is going to be coordinate 0, 1. So this also in radians would be pi over 2. This is 180 degrees, or in radians pi. The coordinates are -1, 0, because you're starting here at the origin. You're going left 1 unit, and you're not going up or down. Here you're going straight down 1 unit. That's going to be 270 degrees, or 3 pi over 2. So this coordinate right here has, this point here has the coordinate 0, -1, and that's -1, 0. This is 0, 1, and then you're back to where you started from. So in terms of the unit circle now, remember SOHCAHTOA. So in the case of the unit circle, the radius is 1. This is x, this is y, so the coordinate of this point right here is going to be x, y. Okay, Now again, sine in terms of unit circle is going to be opposite over adjacent, which is y over 1. So cross multiplying, I get y equals sine theta. Cosine theta is adjacent over the hypotenuse. So that's going to be x over 1. So x is, by cross multiplying, x is cosine theta. Then tangent is y over x again, which is going to be sine theta over cosine theta. So notice that then, since x is also cosine theta, and since y is also sine theta, the coordinate of any point on a unit circle can be written, instead of xy, it can be written as cosine theta sine theta, where this is the angle theta here. I forgot to mention that. I forgot to draw it in the diagram. So this is the angle theta. Okay, so what this means then is I can go around the unit circle, and I can, I'm going to start with cosine. Okay, so I can start with cosine. I'll use red. So that means then that cosine of 0 degrees or 0 radians, so let's actually put these measures in radians here. This is 0. This is pi over 2. This is 3 pi over 2. I'm sorry, this is pi. It's half a turn. Okay. And if you think about it, the circumference of a circle, radius 1, circumference of a circle is 2 pi r. Well, if the radius is 1, the circumference is 2 pi. So a quarter of 2 pi is pi over 2. Half of 2 pi is pi. This is going to be 3 pi over 2 in radians. And then this is also going to be 2 pi, 1 complete turn. So anyway, so now we know that xy, any point on the unit circle, can be expressed as in terms of theta using cosine theta sine theta. So let's start. Cosine of 0 is 1. So I'm going to put that right there, put an x there, and then I'm going to go to pi over 2. Cosine of pi over 2 is 0. So I put an x at 0. I'm sorry, at pi over 2, I mark it as 0. The coordinates, this is going to be the coordinate pi over 2, 0. Then over here at pi, the cosine of pi is -1. So I come down here, that coordinate is pi -1. Then I come to 3 pi over 2, the cosine of 3 pi over 2 is 0. And then back to beginning, the cosine of 2 pi is 1 again. And you could then go a negative rotation. This would be negative pi over 2. So cosine of negative pi over 2 is 0. So that puts me at 0 right here. Then coming in half turn in the clockwise direction, that's negative pi. And that's going to be -1. Cosine of negative pi is -1. Then we come up 3/4 of a turn back up this way in the clockwise direction. Cosine of this will be -3 pi over 2. And that's 0. So cosine of -3 pi over 2 is 0. And finally, we're back again at where we started from. This is -2 pi now. We're going clockwise, and that's to be cosine 1. So then you can draw a smooth curve through all these points. Let's try that again. So that's the basic shape of cosine. You know this is a continuous function because everywhere on, there's infinitely many points on this unit circle, and there are going to be no breaks. There's going to be, between any 2 points here, there's always going to be another point. So this cosine is a continuous function. Okay, it's not broken, it's not discontinuous. We can do the same thing for sine. Now we're going to use, though, the y-coordinate. So I'll do sine in, well, blue is already taken. Let's do, it's kind of hard to see dark blue. So let's use bright green here. So sine of 0 is 1. I'm sorry, sine of 0 is 0 because we're using the y-coordinate. Sine of pi over 2 is 1, which by the way is 90 degrees. Again, this is 0, 90, 180, 270, 360. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is back to 0. Then we could do negative rotation. Sine of negative pi over 2 is -1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is 1. And sine, now we're back to the beginning, sine of negative 2 pi is 0. So sine looks like this. And again, because there's infinitely many points on the unit circle there, this will be a continuous function as well. So that's a basic shape of sine and cosine using the unit circle at multiples of 90 degrees or of pi over 2 to help us get the basic sketch. The curvature comes from, again, there's infinitely many other angles here that we could calculate the sine and cosine of, which will turn out to give it this type of curvature we have where it's a wave motion. Okay, so here's sine and cosine graphed on a computer program. So let's talk about the domain and range of sine. So sine, the domain, it's all real numbers, okay? Because it goes from negative infinity to positive infinity. So domain, I could say, is all real numbers. And the range is from -1 less than or equal to the angle, actually sine theta. So the range is between -1 less than or equal to sine theta less than or equal to 1, and this is all real numbers. Well, it turns out cosine is going to be the exact same thing. It's also all real numbers for the domain. And the range is going to be the same as for sine. Sine and cosine are called sinusoidal functions because they're also periodic. They repeat themselves. And notice that sine and cosine both make a complete cycle in 2 pi. So we say the period is 2 pi. Cosine also does a cycle in 2 pi. So they, again, they're called periodic functions and their period is 2 pi. Alright, so now let's show why cosine squared theta plus sine squared theta equals 1. This is actually a very simple proof, but it's very important. So we're going on our unit circle again, and we remember that xy, we'll do this whole thing again one more time so you get to know it. So sine theta, and this is theta here, sine theta is y over 1, therefore y equals sine theta on a unit circle, radius 1. Cosine theta is going to be x over 1. It's again adjacent over hypotenuse. Again, we're using SOHCAHTOA. So sine was opposite hypotenuse, which is y over 1. So cosine, cross multiplying x, is going to be cosine theta. Then tangent theta is opposite over adjacent, so that's going to be y over x. But y is equal to sine theta, and x is equal to cosine theta. Now, unlike sine and cosine, tangent is discontinuous because the denominator here cannot equal 0. So where cosine theta equals 0, tangent is undefined. That says undefined there. So where does that occur at? That occurs here, and it occurs here. So that is at pi over 2, and that is at 3 pi over 2. And if we go back and look at the graph here, you can see that cosine has a value 0 here, 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 and here. So if I start with pi over 2, notice every pi in either direction, cosine has a value of 0. So we can go back to tangent and say the domain of tangent it's all real numbers except let's try that again. Except pi over 2 plus k pi, where k is an integer. So k is going to be some integer. It could be any negative integer, it could be any positive integer. Again, I'm going back to this previous page here. So if this is pi over 2, it's going to be, so where does cosine equal 0? It's going to be pi over 2 plus pi plus 2 pi plus 3 pi plus 4 pi, pi over 2 minus pi, minus 2 pi, minus 3 pi, etc. So that's where that comes from. So tangent, well, I'm not going to graph it here, is not continuous. Okay, so now let's look at let's come up with our identity. So we can see from the Pythagorean theorem here that x squared plus y squared is 1. So I really should have written this last question down here further. I'm going to slide this down. So notice though again that x is equal to cosine theta. So this is cosine theta squared plus, and y is equal to sine theta. So that is sine theta squared, and that's going to equal 1 squared, which is just 1. Okay, but cosine theta squared, which is how you actually would have to enter it on a calculator, is actually, we usually write as cosine squared theta plus sine squared theta equals 1. So that is the proof, or how that identity is derived. Now where is this identity undefined? It has no places where it's undefined. It is always defined. Okay, so now let's show that 1 plus tangent squared theta equals secant squared theta. So we're going to start with, again, cosine squared theta plus sine squared theta equals 1. So what I'm going to do here is I'm going to divide everything by cosine squared theta. Again, I didn't give myself enough room here, so I'm going to slide this down right here. Alright, well, this is 1. Sine over cosine we showed is tangent, so this is tangent squared theta. And we said the reciprocal of cosine is secant, so this is secant squared theta. There's our identity. Now, where is this thing undefined? Well, we're dividing by cosine again. And we just showed that cosine is undefined here, 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 and here. And this is pi over 2. So this is pi over 2 plus pi k, where k is an integer, pi over 2 minus pi k, where pi could be a negative integer also. So we say that 1 plus tan squared theta equals secant squared theta is undefined where cosine theta equals 0. This is at pi over 2 plus pi k, or k pi, where k is an integer, and integers are your positive, negative, whole numbers, remember. Okay, so finally, show that cotangent squared theta plus 1 is cosecant squared theta. So we use the same process again. Okay, and again I'm going to have to move this down because I haven't given myself enough room. So I'm going to start again with cosine squared theta plus sine squared theta equals 1. But this time I'm going to divide by sine squared theta instead of cosine squared theta. So that is now, remember, tangent is sine over cosine, so cosine over sine is the reciprocal of tangent, which is cotangent. This is 1, and the reciprocal sine is cosecant. So we have this. There's our identity. Now, the problem here is this thing's not going to be defined everywhere. It's going to be undefined wherever sine has a value of 0. So this is at 0 plus, it's actually 0 plus k pi, so we're just going to write k pi. So cotangent squared theta plus 1 equals cosecant squared theta is undefined where sine squared theta equals 0, or sine of theta equals 0. This would be at k pi, where k is an integer. And this concludes our video here. I hope it was helpful. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. That would be really appreciated by me. You may share the content of this video with others. Thank you and have a good day.